Hello friends, welcome to my channel Learn Computer Science and Application. Today in this lecture we will study round robin CPU scheduling algorithm. Round robin scheduling algorithm जो होते हैं they are one of the oldest, simplest and the most widely used algorithm for CPU scheduling. राउंड रॉबिन शेड्यूलिंग में प्रोसेसेस को हम डिस्पैच करते हैं टू सीपीयू इन फर्स्ट आउट मैनर बट इन दिस शेड्यूलिंग ईच प्रोसेस को हम लिमिटेड अमाउंट ऑफ टाइम स्लॉट प्रोवाइड करते हैं फॉर एग्जीक्यूशन विच इज ऑल्सो कॉल्ड टाइम स्लाइस और अ क्वांटम. In this round robin scheduling, if a process is not able to execute to complete in the provided time slice or quantum of time, then the process is preempted by the CPU and placed at the end of the ready queue, and the next time slot or time slice or quantum is given to next process waiting in the ready queue for execution. राउंड रॉबिन शेड्यूलिंग एल्गोरिदम जो होते हैं वो प्रीएम्प्टिव इन नेचर होते हैं एट द एंड ऑफ ईच टाइम स्लाइस और क्वांटम, विच मीन्स अगर एक प्रोसेस इज नॉट एबल टू कंप्लीट इन प्रोवाइडेड टाइम स्लाइस और क्वांटम, then it is preempted by the CPU and placed in the end of the ready queue, and the next time slot or quantum is given to next process waiting in the ready queue for execution. राउंड रॉबिन शेड्यूलिंग एल्गोरिदम जो होते हैं आर वेरी इफेक्टिव फॉर यूज इन टाइम शेयरिंग और इंटरेक्टिव सिस्टम्स बिकॉज दिस टाइम शेयरिंग सिस्टम नीड अ ग्रांटेड रीजनेबल रिस्पॉन्स टाइम. परफॉर्मेंस ऑफ राउंड रॉबिन शेड्यूलिंग जो होता है इट डिपेंड्स ऑन द लेंथ ऑफ क्वांटम और टाइम स्लाइस सिलेक्टेड फॉर एग्जीक्यूशन बाय द सीपीयू. अगर हम क्वांटम ऑफ टाइम को टू शॉर्ट सेलेक्ट करते हैं इट कॉजेज मैनी कॉन्टेक्स्ट स्विचेस बिटवीन द प्रोसेसेस विच रिजल्ट्स इन लोअर सीपीयू एफिशिएंसी. और अगर हम सेट करते हैं क्वांटम टू लॉन्ग इट रिजल्ट्स इन लॉन्ग एवरेज वेटिंग टाइम फॉर प्रोसेसेस एग्जीक्यूटिंग अंडर राउंड रॉबिन शेड्यूलिंग. Below I have explained an example for round robin scheduling algorithm. In this example, there are three processes P1, P2, P3. Process P1 have burst time of 24 milliseconds to get executed by the CPU. Process P2 have a burst time of 3 milliseconds, and lastly, process P3 have burst time of 3 milliseconds again to get executed by the CPU. In this scheduling algorithm, we have selected time slice or quantum of 4 milliseconds for each process to get executed by the CPU. Below I have designed a Gantt chart for round robin scheduling algorithm. In this algorithm, initially the scheduler takes a process P1 for execution and executes it for 4 milliseconds of time first. Then process P1 requires 20 milliseconds of time more for execution, therefore it is put at the end of the ready queue. Now at time 4 milliseconds, scheduler takes a process P2 for execution and executes it for 3 milliseconds to complete. Similarly, at time 7, scheduler takes a process P3 for execution and executes it for 3 milliseconds to complete. In this way, the scheduling proceeds in the processing order as given in Gantt chart above as shown. As you can see in the above Gantt chart, completion time of process P1 is 30 milliseconds. It arrived at 0 milliseconds and its burst time is 24 milliseconds. Therefore, turnaround time is equal to completion time minus arrival time, which is equal to 30 minus 0, which is equal to 30 milliseconds. And waiting time is equal to turnaround time minus burst time, which is equal to 30 minus 24, which is equal to 6 milliseconds. Similarly, for process P2, completion time for process P2 is 7 milliseconds. It arrives at 0 milliseconds and burst time is 3 milliseconds. Therefore, turnaround time is equal to completion time minus arrival time, which is equal to 7 minus 0, which is equal to 7 milliseconds. And waiting time is equal to turnaround time minus burst time, which is equal to 7 minus 3, which is equal to 4 milliseconds. Lastly, for process P3, Completion time is 10 milliseconds. And it arrives at 0 millisecond and its burst time is 3 milliseconds. Therefore, turnaround time is equal to completion time minus arrival time, which is equal to 10 minus 0, which is equal to 10 milliseconds. And lastly, waiting time is equal to turnaround time minus burst time, which is equal to 10 minus 3, which is equal to 7 milliseconds. Therefore, average waiting time is equal to waiting time of process P1 plus waiting time of process P2 plus waiting time of process P3 divided by 3, which is equal to 6 plus 4 plus 7 divided by 3, which is equal to 5.66 milliseconds. स्टूडेंट्स, उम्मीद है आपको मेरा लेक्चर पसंद आया होगा। अगर पसंद आया है तो लाइक करें, शेयर करें, बेल आइकन को प्रेस करें और चैनल को सब्सक्राइब करना ना भूलें। थैंक्स फॉर वॉचिंग गाइस, थैंक यू।